Have you ever stopped to think about the incredible, invisible forces at work all around us? There's a hidden power that's literally moving our world, from the cars we drive to the jets in the sky. Well, today, we're going to pull back the curtain and take a look. So let's just jump right in with a question that sounds, kind of impossible, right? How could you possibly lift a car with just one hand? No, it's not a superpower. It's science. And it's a principle you probably use every single day without even realizing it. I mean, think about it. This is the same force that can launch a fighter jet off an aircraft carrier or move literal tons of earth with a bulldozer. It's what stops your speeding car with just a little tap of your foot. And it's how a mechanic can hoist a heavy vehicle up on a garage lift. So what is this thing? What's the secret? The answer is this incredibly powerful yet totally invisible principle that is constantly at work all around us. It's not magic, even though what it does feels pretty magical. It's time to meet the hero of our story, fluid power. You can think of it as the engine you can't see, the invisible workhorse that drives so much of our modern world. And yeah, it's the answer to our car lifting puzzle. Okay, so what is fluid power really? Well, the official definition is right there. It's using pumped or compressed fluids, and that can be liquids or gases, to generate and control force and motion. Put simply, we're making liquids and gases do all the heavy lifting for us. Now, fluid power isn't just one thing. It's got two main flavors. On one hand, you've got hydraulics. That's when we use liquids, like oil. This is for when you need massive force and really precise control. Think of those giant yellow excavators on a construction site. On the other hand, you've got pneumatics. That uses gases, usually air, for things that need to be super fast but don't need quite as much muscle. But how? How does just squeezing a fluid create so much raw power? Well, the answer comes down to one simple, elegant rule, a big secret discovered centuries ago that pretty much changed everything. And here it is, the secret sauce. It's called Pascal's law, named after the brilliant scientist Blaise Pascal. And it says that pressure on a confined fluid is transmitted, get this, undiminished and in all directions. Those two ideas right there, they're the whole ballgame. Okay, check this out. This image shows it perfectly. If you take a hammer and hit a solid bar, that force pretty much goes in one straight line. Simple enough. But if you apply pressure to a fluid that's trapped in a container, that pressure doesn't just go forward. No, it pushes out equally, everywhere, all at once. Up, down, sideways, everywhere. And if you want a perfect real-world example of this, just think of a fire hose. When it's empty, it's just a flat, limp piece of fabric. But the second you pump water through it, what happens? The pressure inside pushes out equally on every single part of that hose, forcing it into that stiff, perfectly round shape. That's Pascal's law, right there in front of you. All right, so we get the principle. Pressure pushes everywhere. Now for the really cool part. Let's see how we use that idea to turn a tiny little push into an absolutely mighty shove. This is where the magic really happens. And believe it or not, the entire trick comes down to this super simple little formula. Force equals pressure times area. That's it. Those three little words are how we multiply force and get something for almost nothing. Let's break it down. Okay, let's walk through it. Look at this setup here. Step 1. We apply a pretty small force, just 20 pounds, onto that small piston on the left. Step 2. That piston has a surface area of just 2 square inches. Now, that 20 pounds over 2 square inches creates 10 pounds per square inch, or 10 psi of pressure, throughout the entire fluid. And here's the key. That 10 psi of pressure is now pushing on that big piston on the right, which has a much larger area of 20 square inches. So, we've got 10 pounds of pressure pushing on every single one of those 20 square inches. Any guesses? What do you think the final output force is going to be? 200 pounds. A whopping 200 pounds of force. It's kind of mind-blowing when you see the numbers, right? It all comes from that beautiful, simple relationship between pressure and area. Let's just stop and appreciate that. We put in 20 pounds of force, something you could do with one hand, and we got 200 pounds of force out the other side. That's a 10 times multiplication of our effort. And all we did was change the size of the pistons. And this isn't just some neat physics trick in a textbook. This is happening all around you every single day. It's the power that stops your car, and it's the power that builds our cities with giant cranes. Now, of course, no system is perfect. There are always trade-offs. The amazing part about fluid power is that it's super smooth, it's flexible, and you can control it remotely. But the downside? Well, to hold all that pressure, you need really strong heavy-duty pipes and containers. And leaks are a huge problem. We're not talking about a little drip. A hydraulic leak can be a dangerous high-pressure spray. But the impact is just undeniable. So the next time you tap your brakes, or use power steering, or even lean back in a barber's chair, now you know the secret. You're watching fluid power do the heavy lifting right there in front of you. So now you're in on the secret of fluid power. And it kind of makes you wonder, doesn't it? What other incredible, invisible forces are out there quietly shaping our world every single day, just waiting to be discovered?